Yeah.
We can indeed, yeah.
Yeah. So
Okay.
Okay. Can you share your screen as well?
Okay, yeah, I can. Let me do that. Okay. Okay. Present. Okay. So I think we're ready.
Amazing. Yes, we are. Take it away. Thank you so much.
Okay, thank you guys. Like Fidel said, my name is Joy Utos. The U at the end is actually silent. I'm the engineering manager of Secluded and Storehouse. Like I said earlier, Secluded is actually a lending platform for women. So I'm a core backend engineer. I use Java, Python, and also kind of like a machine learning engineer too. Today, I'm going to be talking about beginner's lookbook at object-oriented programming. The reason I chose this topic is because most mentors, like most mentees I had to work with, like a lot of them shy away from OPs. Like I don't know the impression that they've gotten over time, and they just like, no, I don't want, like it looks so stressful. Let's just stick to procedural. So I want to just kind of lay a foundation for anybody that wants to, that has this idea that OP is tough. I want to lay a foundation so that you would like have an overview of what object-oriented programming is about. So our talk context is what is object-oriented programming, the building blocks of object-oriented programming, 4 principles of OOPs and benefits of OOPs, and then core OOP languages. So let's just get started with our talk. What is object-oriented programming? So according to my off the book definition, I said object-oriented programming is a programming paradigm that relies on concept of classes and objects. Well, okay, let me just try to make that more human readable. So basically, object-oriented programming, like it helps to like explain the relationship between objects, like how these objects interact with each other, and also how these objects come together to form a complex structures, not only the object, the classes, methods, the attributes. Now, these objects usually contain data and code. Data in the form of attributes, which are also variables and fields. Like if we're familiar with programming terms, we know what variables are. Variables are kind of like containers that are used to hold values, basically. So while methods are procedures, like actions that these classes can perform, basically. So I also said that OP is used to structure software into, like, which is true. Like so if we want to create a complex structure, object-oriented programming helps us to create layers, like so that we won't just model everything up, and so that we won't have to like write what we've written before. It helps to put everything in modules and packages so that if we've written something before, we can if we use what we've already written before. If we have so it just helps to create like a clean structure for application development. So there are some, so let me just go on to the building blocks of object-oriented programming. So there are 4 building blocks of object-oriented programming. We have objects, classes, attributes, and methods. So I have this illustration here that kind of gives an overview of the relationship between these classes, methods, attributes, and objects. So we have a class car, and inside that class, we have 2 attributes. Also, we have 2 methods. And then this class can be instantiated to form objects, which are the Toyota Camry, Box, and BMW X6 that we have. But subsequently, I'll break each and every one of these building blocks down so that everybody can understand them. So let's just go to objects now. So what are objects? Objects are basically instances of a class. Like you have a class. If you want to use that class that you've created and replicate it in another form, you need an object to create an instance of that class. Like create like if you look at our previous slide, we have a class car, right? If I want to create an instance of the car, like an example of the car, all I just need to do is to create an object of that car. And to create object, we need a constructor to create an object. So this constructor, we can have no arguments. We can have all the arguments. You can decide to create the constructor without passing any of the attributes that exist in that class, or you can decide to create the constructor passing values for each and every one of the attributes that exist in the class, right? So like I explained in my slide, I said in this case, the objects are created from the class car. We have Camry, which is an object that was created from car. This object would have every feature that this car has. Like it's kind of like the basic unit of object-oriented programming. So it would have, if you create this Toyota Camry automatically has two attributes called color and speed. And also it has two methods, stop car and start car. Also the same with the Innocent and the same with the BMW. So the object is just like creating replicas of the car that you've created previously. That's the class. So now let's go to classes, methods, and attributes. What is a class? A class is basically the blueprint for which an entity is created. How I like to define it is I'll say a class is kind of like the DNA of the object. Like it tells you about the object. Oh, a car, what do you expect from a car, right? Okay, the car should have a color. Like how fast is the car? How much did you get the car? So it actually tells you about the object. Like a class tells you about the object. It's kind of like the DNA of the object. It holds the data types that are contained in that object. And also it also tells you about all the actions that can be performed from that object. Like, okay, from our slide, from the fourth slide, we saw that we have two actions that can be performed on the car that we created. We can either start the car or stop the car. So a car can also even contain a constructor, which can be used to create an object. But for your understanding, I just want you to know that a car is kind of like the DNA of the object, like where the object originated from, like the ground, the foundation of the object, basically. So let us so a class can have access modifiers, right? You can either make your class public, you can make it private, you can make it protected. So these access modifiers are kind of like ways in which these classes can be used or reused, like they determine the accessibility and the visibility of the class that is being created. And access modifiers can also apply not only to class, it can apply to methods, it can apply to attributes, it can apply to constructors, right? Once you indicate an access modifier, you have kind of said, okay, there are various types, you have public, we have private, so if you say you want to make a class public, that means, okay, everybody can access the class, it's open for everyone, right? But if you say you want to make it private, like automatically you have restricted the accessibility of the class that you've created. So now inside the class, we have some features in which you always find in a class. That means we have the method inside the class. We have these methods are kind of like procedures and behaviors of the class, right? We have the attributes. Attributes are variables. Like, I don't want anybody to be confused when you hear attributes. It's the same variables you know in programming, right? Variables, fields, those are attributes basically. So now let's talk about the attributes, right? So attributes are kind of containers that can hold data within a class. They are mediums in which data can be stored within a class. Attributes can have access modifiers, and also these attributes will be initialized with a data type. Okay, let me break that down. Like I've already explained about access modifiers a few minutes ago. Like you can also make an attribute private, you can make it public, you can make it protected. But like I said, whichever access modifier you use determines the accessibility of that particular attribute in the class. So now, when you're creating attributes within a class, you can either have class variables or instance variables. Class variables are kind of members of that class. no matter how many instances of the class you create, those class variables will always remain the same. They are always created with this keyword called static. So once you initialize a variable with the keyword static, that means that variable belongs to that class. Even if you create an object, you can't really change the form of that variable. For every instance you create, that class variable will be in that object. But instance variables are variables that transcends over objects, right? So when you create an object, it has its own instance variable. Okay, let me break that down with the example I used earlier. That's the car example. Now we have a car. We have color in our car. Let me go back so that it will be clear. So we have two attributes, color and speed, right? If I create this color and speed, if they are instance variables, right? When this color and speed are created, the color can change. You can say, okay, I'm creating a black BMW, or I'm creating a red Toyota Camry. So these class variables, they transcend over the objects. It's not just, they don't belong to the class, basically. They change according to the object. So now, like I said, we have two features, right? Modifiers and then data types. Now let's go to data types. Data types determines the kind of data that that variable holds. So what do I mean by that? Now we have a variable called, an attribute called color. If I'm going to assign a data type to that attribute, I'll assign it as a string, because the color can be either red, blue, green, anything. So I'll just make it a string to kind of open up my possibilities of colors. I can't say an integer because I don't really know if there are integer assignments of colors, but when you say string, it's more humanly understandable. So I can also use another example that has to do with maybe shapes. Shapes, I create a class called shapes. Now I have number of sides, right? If I'm going to assign a data type to number of sides, I would automatically use an integer, because I won't use a double, because a double accepts decimal numbers, right? So if I'm creating number of size, you can't expect a shape that has 3.5 as its number of size. No. So you use an integer that has a finite value without any decimal value attached to it. So for data types, for most object-oriented programming, like I'll talk about Java, we have two data types, either primitive data types or reference data type. There are 8 primitive data types, which are integers, long, short, floats, Boolean, byte, char, and what's the last one? Byte, char, and short. So these data types, they are kind of members of the language. Like you can't even create a variables with those data types. When you try to run your code, it will even give you a syntax error. So these data types, the compiler sees it like it has special meaning to the compiler. But for your reference type, you have like string, big decimal. They were created, but they've been used, like they're just classes that have been created and have been used over time. Like, and they are now part of the package, basically. So that is basically that's about attributes. Now let's talk about methods, right? What are methods? Methods are, they perform actions. Method might return information about the object. Yeah, we know all that. But if I'm going to talk about methods, I'll say methods kind of determine the behavior of the class, and also the kind of functions that this class can perform. What can this class do? We created a class here called car. From this illustration, we can see that you can either stop the car or start the car. We can have more methods for this car. We can add more, like we can have as many methods as possible. We can even have a buy car as a method. So like you can help you, okay, I want to buy a car. How do I go about it? So now methods also have some features, right? You can have access modifiers, you can have input values and output values. Now, for my start car, I can decide to take in a value, should I say, let me just say a list of, I can take in an integer value for my start car. I can say if, okay, I'm expecting an integer, right? Between the value 0 to 10. I can say if this integer, I will name it, should I say fuel tank? say if the fuel tank is between 1 and 10, return boolean that's true or false. That's for true for starts, false don't start. So inside my start car, I would have this little procedure inside of it, and I would say once you pass in a value, you pass in 6, it does a check. 6 is between 1 to 10. What does it do? It returns true. That means the car starts. But once you pass in a value of 0 and it sees that, oh, that means the fuel tank is empty, oh, don't start the car. So that's just basically what methods are about. They kind of help us to perform functions within a class, right? So let us go on to the 4 principles of OOPs. I'm actually excited about this one because the words, like sometimes when people see the words, they're like, "Oh, these words are looking very scary." But now we're going to break it down to as many bits as possible. So we have 4 principles of OOP, which is encapsulation, abstraction, intelligent, inheritance, sorry, and polymorphism. Now let's break that down. Okay, by 4 principles, I just mean like everything object-oriented programming, if you are going to trace it back to origin, realize that it falls within the context of these 4 terms that I just listed out. Okay, now let me explain what we mean by encapsulation. According to my definition, I said that encapsulation refers to the bundling of data along with the methods that operates in the data into a single unit. For this example, I'm going to use a little family, right? So assuming we have a little girl, her name is Ada. She has 2 pets, let's say lucky and unlucky. She lives with her parents. So Ada lives in the house with her parents. The doors are locked, the windows are shut, and everybody is within that context. But guess what? She forgot to take her one of her pets inside the house, which is unlucky. Unlucky is sitting outside the front porch. Now, Ada and her family and one of her pet, Lucky, and her parents are encapsulated, like protected within the um, class called the house. So now intruders can't just go in and do anything to any of them. No, like you have to request access. If you want to have any access to them, you have to ring the doorbell and say, hey, I want to do something. So that's really what the encapsulation is about. It actually kind of it bundles up the data within the class and restrict access of things going out and coming in. Um, it's actually a very good way of protecting the class. In fact, it is really important in OOPs. And how do we go about this encapsulation? It's also the use of access modifiers like I've mentioned before. So if you make your class private, you have restricted access. It's just like Ada's house being shut. You have made the house shut and then nobody can just come in here. So that's like a private class. But guess what? If you make it public, that's unlucky sitting outside. Somebody can just take Lucky home. And that's what Lucky is outside of the encapsulated class. So that's really what encapsulation is about. So now let's talk about abstraction, right? I have like my, as usual, my textbook definition, but if I'm going to just give you like a more understandable, I would say abstraction is a way of reducing the complexity in which objects interact with each other. Okay, let me use one example that is very understandable by everybody. I have a dishwasher in my house and I have a dirty dish. If I want to wash this dirty dish, will I just start using a screwdriver to open up the dishwasher? No, I won't. I'll just put my dish in the washer and then I get a clean dish. I don't even need to know the mechanism of how the dishwasher operates. No. All I just need to know is put the dishwasher, start the machine, and then I get clean dish. Same applies to the washing machine. If you have a washing machine in your house, if you want to wash your clothes, do you dismantle the machine and then try to see what's going on? Oh, the stuff is spinning. I need to see what's happening. No, you just put your washing machine. You put everything that the washing machine expects you to put. Those are the variables that are expected, right? So you put your water, put your detergent, and then you close it and you start the washer. You don't need to know the mechanism of the engineering of the washing machine. All you just need to know is the basic functions of the machine, and it does your work for you. So the whole idea of abstraction in OOP is actually just removing all the complexities from all the objects that are interacting with each other. If you need a function, just take the function, do whatever you need to do, and then give me results. The same goes to Ada. If Ada gets a mail from school and then they send the mailman to her house, the mom can stand in place and get the mail from the mailman. Would the mailman say, no, 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 I can't give you this mail unless it's Ada? No. The mailman gives the mail to somebody in the house, knowing that the mail would end up getting into the possession of Ada. So that process of just removing her from the, like, her mom standing in place, her mom can be an interface, her mom can be an abstract class, like in context, right? So at the end of the day, she gets, sometimes she may not even really need to read the letter herself. She just needs to ask her mom, oh mom, I got a mail from school, what do I have to do? The mom tells her, oh, this is what came in from school, this is what you have to do, and then that's that. So I'm trying to be fast so that I can I can keep up with time. So now let's go all the way next to inheritance. So inheritance is a mechanism that allows one class to gain the properties of another class. So in this case, we have the inheritance is in programming, funny enough, is the same thing as inheritance in real life settings. You have a parent and then a child. The child gets properties from the parents, basically. So the parent is superclass, the child is a subclass. So if we have a class called shapes, which is a parent class, and then we can create subclasses like circle from class shape, right? Because circle is also a shape. Now, if this class shape has properties like number of sides and area and, should I say, circumference, when you create the class circle, you don't even need to initialize these variables in your circle. All you just need to do is create the circle and extend the parent class. Automatically, it gets the characters of this parent class. Also, if there are methods in that class, it also gets the methods in that class. So, okay, let me just hurry up and go to the next one, polymorphism. I like explaining this one because it's fun. So, polymorphism, the Greek meaning is actually many shapes, right? But polymorphism, sorry, it's objects taking different forms. So let me use myself as an instance, right? I'm a foodie, I love food. My sisters will call me a foodie in the house. Now, I am a software engineer. When I go to the office, my colleagues will say, oh, wow, a badass software engineer. If I go to church, my church members will call me a good Christian sisters. To me, I I don't know. I call myself a dancer. I don't know if I can dance, but in my head, I can actually dance very well. So you see, all these many personalities I have does not change the fact that my name is Joy. Even if I'm a Christian sister, I can be a software engineer, I can be a dancer and a foodie. But no matter what happens, I would always remain Joy. And that's what polymorphism is about, is objects taking different forms, right? So let me break that down. Let me bring that back to software engineering, variables and classes. Now you have a class, an interface called car, right? Like we explained earlier. Now, if I want to create a class from car, another class, let me say sports car. Remember, we already have two methods in car, which is start car and stop car. If I want to create that my sports car and I want it to take a different form entirely, how do I bring in the principle of polymorphism? I would have to override the method that exists in car, that's start car method. Now, all the other methods, if all other, should I say all other, maybe a lorry or a taxi is created from car, they take the principles of car. Like when you want to start it, if you have 1 to 10, it starts. If it's 0, it does not start. But now I can override that method and add a, should I say, a condition that says, okay, even if it's between 1 to 10 and it has an extra tank, start the car, else don't start the car. Automatically that my sports car has taken a new shape. Even though is getting its property from a parent class, it has its own characteristics such that if normally other cars that comes out from that parent, if it's 0, it does not start, right? If it's 1 to 10, it starts. But this one, if it's 0, it does another check. Okay, it's 0. What happens? Do we have an extra fuel tank? If it has an extra fuel tank, it starts. Otherwise, it does not start. So I hope I've been able to explain polymorphism very well for us. Let me hurry up. Now, benefits of OOP. So OOP, reusable. So like I said earlier, like one of the most beautiful thing about OOP is not having to rewrite things. You don't have to go through the pain of creating car. No. All you just need to do is to have your parent car and you have other cars inherit from the parent car, and everything looks clean and understandable. So allows for class specific behavior through polymorphism. Like I said before, like I just explained a few minutes ago, like I can create a sports car and that car would have its own characteristics. Object-oriented is easier to debug because it's class-based, right? You just look at the class and you know where the issue is coming from. Secure. Access modifiers. If I don't want you to access my house, I just make it private, I make it protected. So you can't access those methods or classes from outside. So OOP also models complex things so exactly, like it actually reduces the complexities. Like I explained about the washing machine, you just create simple structures and puts them together, makes it very easy for everyone to understand. So also it allows classes to take different forms. Like I said, me, I I'm a dancer and everything, but I'm also Joy. So this is the same thing with the class. No matter how many sports cars you create from that class car will always be car, right? It will always have its own characteristics. If you want to override, you can use method overriding and method overloading and bring in the principle of polymorphism into play. So languages that support OOP. So these are basically the languages that there are other languages. We have like new languages like Dart. We have Swift. Like I didn't list them all out here, but these are just the ones that I put out. Well, you can check out more on OOP to get all the other classes. Thank you, everyone. My LinkedIn, Joy, my Twitter, Joy Utos, and it was nice having this talk. I don't know if you guys have any questions for me. I think I still have 2 minutes.
We do have questions.
Yeah.
Thank you so much for that. Firstly, I'm just going to reiterate the plug. Make sure you are following Joy on Twitter and send a request on LinkedIn if you'd like to discuss this further. It's just one question really, but it's a big one that we could probably talk about this for a long time. So the question was, can you please enlighten us how they compare to functional programming and when to use what?
Oh, okay. So object-oriented functional programming just involves the uses of functions. You don't have to bother about classes and structures. You just get the functions and they do the work for you. Like when computers were created, it's just a device that has one single function, right? The reason why OSs was even invented was because other functions came about, and then you just iterate through those functions, and then it does the work for you. So object-oriented programming kind of, should I say, structures it in sense that even if you have a function within a class that is used, you can go ahead and use that function again. But functional programming just, okay, you have a function, you use the function. If you want to create another function, you can create as multiple functions as possible to do your work, basically. So I don't know if I was able to explain that properly.
You did, yeah. I mean, I knew the answer, but I kind of wanted this person to hear it from you. And yeah, I totally agree with what you said. And just one other thing, just before I go, I just want to say that there has been a lot of compliments about the examples that you've used to explain these concepts. A lot of people are really loving the real life practical examples that they can relate to. So definitely big kudos to you. Well done.
Thank you very much. It was really nice being here with you guys. Like,
awesome.
It was cool. So,
thank you so much. Okay, so back to my main man, Fidel, to introduce our next speaker. Fidel, over to you.
Thanks, Rob. Joy, big round of applause for you. I think the only point you missed was telling us your car. It seems like you're a car lover. You skipped that. You should have we know you're a Ferrari person and stuff. No, real good, real good.